Diabase. What you are looking at is often described as the best preserved volcano in Brazil. Known as Pico do Cabugi, this long-extinct system rises 430 meters or 1,410 feet above the surrounding landscape with a profile somewhat similar to an eroded cinder cone. And yet, Pico do Cabugi is not actually a volcano at all. Instead, while it did form due to the presence of ancient magma, it could best be described as a volcanic neck, with what we see today having originally formed below ground level at a depth of up to 2 kilometers or 6,560 feet. How do we know this, you might ask? Simply put, when magma of the same composition is emplaced in the crust at deeper than 2 kilometers depth, between 0 and 2 kilometers depth, and above ground, it will form different rock types which can be identified. In the case of magma, which has between 45% and 52% silicon dioxide by weight, from deepest to shallowest it will form the rock types of gabbro, diabase, and basalt. Note how as you get deeper in the crust, the size of the crystals which form drastically increases, as crystal size is determined in part by the length of time it cools for. The longer a crystal cools for, the larger it gets. And, the deeper you go in the crust, the hotter the surrounding rock is, causing solidifying magma to take longer cool. In the case of Pico do Cabugi, the specific rock type is composed of as diabase, meaning it represents a 500-meter wide core of an ancient magmatic intrusion. While this intrusion could have been technically linked to a volcano long ago, there is no direct evidence that one existed, with it being more likely that the modern Pico do Cabugi represents a portion of a failed magmatic intrusion which remained completely below ground level. As a whole, Pico do Cabugi formed around 24.6 million years ago involving low silica molten rock. So, why exactly did this magmatic intrusion occur in the first place in Brazil during the Oligocene period? Hotspot related? The answer has to do with a broad cluster of volcanoes which formed along a 25-kilometer wide from east to west and 100-kilometer long from north to south area which composes what is known as the ancient Macau volcanic field. For many years it was suspected that these features formed in association with a mantle plume or hotspot to the north that formed a chain of seamounts which led to Fernando de Noronha Island. However, this assertion was later proven to be incorrect as hotspot chains only parallel the movement of a tectonic plate since the overlying tectonic plate moves and the underlying hotspot largely does not. Thus, if the Noronha hotspot was to have existed, since plate motion has moved progressively towards the northwest, you would expect a chain of volcanoes in that orientation instead of perfectly west to east. Craton with a hotspot out of consideration, why then did Brazil suddenly experience a cluster of volcanoes which erupted from 40 to 10 million years ago? The answer relates to the proximity of an unusually thick and solid piece of crust which is rather cold known as a craton. In this case, the São Francisco craton. Edge convection. This craton is around 2.5 billion years old and is 15 kilometers thicker than the region around Pico do Cabugi. This region approximately 24.6 million years ago experienced what is known as edge convection. The cold material in the São Francisco craton cooled adjacent material in the mantle, causing it to fall downwards. As hotter material moved to replace the falling cooler material, it created a weak cyclical motion. This motion allowed for molten rock to intrude into the crust and produce a series of intrusions and eruptions more than 10 million years ago. I hope that you enjoyed this video. Please let me know if you want me to cover more geologic features in Brazil.